Welcome back to Module 4, the economic valuation of the impacts of climate change in agriculture and natural resource management. Our next topic is the economic valuation tools, which we will be discussing in two parts. Again, let's bring back this slide from Module 1, which shows the potential impact of climate change in agriculture, water resources, forestry, and ecosystem, health, and extreme weather events. We can see that indeed there are many impacts of climate change that we need to value, and we also need to and costs of adaptation measures. From Module 1, Rodell discussed several possible adaptation measures, such as to bear the losses, meaning we do nothing, to share the losses among a wider community, such as our extended families, to modify the threat, if there is a degree of control over the threat, as in the case of flood control, to prevent effects, for example, changes in crop management, such as provision of irrigation, to change use by substituting drought-tolerant crops, or to change the location of economic activities. Let's look at some value estimates of damage due to extreme events, such as La Niña and tropical cyclones. In Indonesia, the damage to infrastructure due to floods in 2003 to 2005 was placed at about $205 million. In the Philippines, the annual damage to property of about $83 million and annual average of 593 deaths from 1975 to 2002 were estimated, with damage to agriculture placed at $55 million. In Thailand, economic losses of $1.75 billion were estimated due to floods, storms, and droughts from 1989 to 2002, with $1.25 billion coming from agricultural crop yield losses in 1991 to 2000. In Vietnam, the damage to farmland and fish and shrimp ponds was placed at $680 million, with 1,684 deaths between 1996 and 2001. In Indonesia, an increased incidence of forest fires was observed during the El Niño years, and forest fire damage that also adversely affected the agriculture, forestry, and other sectors was placed at $662 million to $17 billion in 1997. And so we ask, where did the values come from? Let's look at the possible valuation approaches for climate change impacts and adaptation. Impacts on agriculture, such as increasing potential of crop yields, falling crop yields, the loss of agricultural lands due to sea level rise, or delays in current cropping schedules, can be valued using price-based techniques. On the other hand, adaptation measures can be valued by looking at the cost of adaptation measure or the cost of damage avoided for the costs and benefits respectively. In the case of water resources, the impact on the increasing population under water stress, increased water runoff, or decreasing quality of aquifer and groundwater resources can be valued by looking at the cost of alternative water supply, the travel cost method, the price-based technique, the cost of alternative water supply, or the cost of treating water. In the case of adaptation, we can look at the cost of adaptation measure using price-based and other techniques, or the cost of damage avoided. For forestry and ecosystems, impacts such as the replacement of tropical forests by savannas and shrublands can be valued by looking at the reduced forest productivity based on price-based techniques or restoration cost and replacement cost. On the other hand, the impact of biodiversity loss can be valued using the contingent valuation method, which can look at willingness to pay or willingness to accept. Adaptation can still be valued using the cost of adaptation measure for the cost or the cost of damage avoided for the benefit. At this point, let me introduce the concept of total economic value. We have here a simple formula which says that total economic value is equal to use value and non-use value. Use values arise from the actual use of a resource, and examples are the use of a wetland for recreation or fishing, or harvesting timber from a forest. Furthermore, use values are composed of direct use values, such as actual uses like fishing or timber extraction, indirect use values, or benefits that arise from an ecosystem's functions, for example, the function of a forest in watershed protection, and option values, which express an individual's willingness to pay to protect or safeguard an asset for the option of using it in the future. Thus, use values consist of direct use values, indirect use values, and option values. Next, let's look at the non-use values. These include bequest value and existence value. Bequest value measures the benefits that accrue to an individual from knowing that a resource will provide benefits to the future generation. On the other hand, existence value, which is also known as passive use value, measures an individual's willingness to pay, or what we call WTP, for the assurance that a resource will exist even if there will be no actual use. Thus, non-use values equals bequest value plus existence value. And to summarize, total economic value equals use value plus non-use value, and use values equal direct use value, indirect use value, and option value, while non-use value consists of bequest value and existence value. Let us now look at the categories of valuation techniques. We have price-based approaches, related goods approach, the indirect approaches under which are surrogate markets and conventional market approach, direct approaches such as the contingent valuation method, cost-based methods, and benefits transfer. For the remainder of this lecture, we will be talking about the first two valuation techniques and proceed with the other four in the next lecture. So let's look at the first valuation technique, which is based on market prices. Here, we use market prices of goods and services corrected for market imperfections and policy failures that may distort prices. Under this technique, we always consider the net value and not the gross value. This means that all harvest and transport costs should be deducted from the market or gross price. The second valuation technique is the related goods approach, under which we have barter exchange approach, and some of you may have actually experienced doing barter trade, and the direct substitute approach, which estimates the value of a non-market good or service from the value or price of substitutes or comparable goods and services. For example, the value of fuel wood harvested from the forest can be compared with the price of fuel wood from other areas, or with kerosene or charcoal. We have come to the end of part 1 of the lecture on economic valuation tools. We will discuss the 4